In this video, we're going to go through some final exam review problems. So here we're going to start with a problem about average rate of change. So the height of a tree in inches is recorded at the following times. Find the average rate of change in the height between the following, include units. So there's kind of two things we want to point out right now. First of all, what's the formula for average rate of change? The formula for average rate of change is going to be f of b minus f of a over b minus a, where f is my function. In this case, that's going to be like h, and then b and a, those are going to be the input. So like change in output over change in input. What are the units on those things? Well, the output is recorded in inches, and the input is recorded in months. So the units here are going to be inches per month. So let's go ahead and put all this together. If we're looking between 6 and 10, that's going to be h of 10 minus h of 6 over 10 minus 6. In this case, my a is 6, my b is 10. What are those going to be? H of 10 looks like it's going to be 9. H of 6 looks like it's going to be 4. And I'm just using this table to answer those. Over 10 minus 6. It's going to be 5/4. So my answer is going to be 5/4 inches per month. Oh, that was weird. We're back. Okay. What about between 10 and 20? Well, let's do the same process. Now my A is 10, my B is 20, so we're going to have h of 20 minus h of 10 over 20 minus 10. H of 20 looks like it's going to be 21. H of 10 looks like it's going to be 9, like it was earlier. No surprises there. And then we're going to have 20 minus 10 still down there. That's going to be 12 over 10, which if you wanted to, it might be nice to think of that as 1.2, but I'm not going to do that. I can simplify that down, though, to 6 over 5. So here my answer is going to be 6/5 inches per month. There we go. So we have the change, the average rate of change for those different times. All right, let's take a look at the next part. Next, we're going to do some inverse functions. And one of these is a little different than inverse functions we've done before, but that's okay. We'll see that we can actually do it using tools that we already have, which is great. So whenever I find an inverse function, I'm going to start by replacing that f of x with a y. And then I'm going to flip the x's and the y's and then solve for y. So we have x equals 3/4 y minus 5. Now I need to get y by itself. There's this 5 over here which I need to get rid of. So I'll have x plus 5 equals 3/4 y. And just to make sure we're feeling good with our fractions, 3/4, to cancel out this 3/4, what I want to do is I want to multiply by 4/3. Now, you had another option here. What you could have done is you could have started off before subtracting that 5. You could have multiplied both sides by 4 to clear the fractions. That would have worked too. Here's how we're going to do it today, though. So I'm going to cancel out this 3/4 by multiplying by 4/3. And what I do to one side, I have to do to the other. So here I'm going to get that 4/3 x plus 4/3 times 5. Let's do a little scratch work there. That's going to be 4/3 times 5 over 1. That's going to be 20 over 3 equals y. So that's going to be my inverse function. And we could write out a final answer that looks like f inverse of x equals 4/3 x plus 20 over 3. Okay. So we did one. Now we get to the tricky one, but let's kind of follow our nose and do the kinds of things we would normally do. So I'll start by writing y equals 3 natural log of x plus 2, and then I'll flip the x's and the y's. Oh, there's a plus sign there. And then usually when I'm solving and I have something inside of a natural log, I want to start by getting the natural log by itself. So we'll do that same thing here. So to do that, I'm going to start by subtracting 3 from both sides to get x minus 3 equals natural log of y plus 2. And then if I want to undo a natural log, what I'm going to do is I'm going to do e to the power of both sides. That's going to get me e to the power of x minus 3 equals this e to the power and the natural log. They cancel out, so I get y plus 2. So that was a little tricky, but we've done that kind of thing when we just solve normal log functions, so it's not too crazy to do that when finding an inverse function. So we get e to the x minus 3 equals y plus 2. And last but not least, I'll subtract 2 from both sides to get that y equals e to the x minus 3 minus 2. And we get that f inverse of x equals e to the x minus 3 minus 2. And that's good. So we have our answer there. So last but not least, here's a problem which is on the harder side of our inverse function solves. But we're going to follow the same steps. Start by writing y equals 2x over 3x minus 6, and then we'll flip the x's and the y's. And the problem here is that I have y's in the numerator and the denominator. So the first thing I'm going to do is clear the fractions. Sometimes I might have something added or subtracted, and if that's the case, then I want to kind of make it so that this is just a fraction before I do that. But that's not the case here. I just have 2y over 3y minus 6, so I can clear the fractions by multiplying by 3y minus 6 to both sides. If you have to add or subtract something first, that means you're going to have to FOIL when you do this. So be careful. Those cancel, and I end up with 3xy minus 6x equals 2y. What do I do next? Well, I want to take everything that has a y in it and put it together, and then take everything that doesn't have a y in it and move it to the other side. So it looks like the easiest way to do that in this case will be to subtract 3xy from both sides. When I do that, I'll end up with negative 6x equals 2y minus 3xy. And why did I do that? Well, first of all, now I have everything on this side has a y. Nothing on this side has a y, so we're good to go there. And then I want to factor out that y. So we'll factor it out. And when I factor it out, I'm left with something like this. And to finish solving, I'll just go ahead and divide by what's being multiplied to y. That gets me that y equals negative 6x over 2 minus 3x. And that's a perfectly fine answer. I'm going to do something a little picky. I don't like having this negative up here and a negative in front of the x there. So what I could do is I can multiply both sides by -1. And this is totally unnecessary, but I'm going to do it just to clean up my answer. That will get me 6x over -2 plus 3x, which I could then rewrite as 6x over 3x minus 2, which is a little bit nicer. And that is going to be my inverse function. So there we go. There's some review with inverse functions. And with that, let's move on to the next page. That didn't take all too long. So we'll go ahead to the next page. Maybe we'll do a couple of these and then split up for the next one. So here we're going to be solving some equations. We'll do the top 2 here, and then we'll save the other 4 for the next video. So here I have an absolute value problem. Kind of like with log functions and with trig functions, the first thing you want to do is get this part by itself. So let's go ahead and do that. I'm going to do that by adding 10 to both sides. So we'll have absolute value of 3x plus 5 equals 10. And then this splits up into 2 different equations. To get rid of the absolute value sign, I'll split it up into 3x plus 5 equals positive 10 and 3x plus 5 equals negative 10. And each of these are not the worst solve that you've seen in your life. We get x equals 5/3. And then over here, we'll get 3x equals negative 15. Oops, negative 15. divide by 3, divide by 3, x equals -5. So those are going to be my two solutions. There's two solutions to this equation. And there we go. Okay, now we'll move on to this trig solve, which is a little bit harder. So once again, my first goal is to get this tangent by itself. And there's a few different ways to do that. Here's what we're going to do. I'm going to start by getting this fraction by itself. So we'll go ahead and subtract 3 from both sides. We'll get 1 equals 3 over tangent of 2x plus 4. And then a few different ways you can do this problem. What I'll do is I'm going to clear the fractions by multiplying both sides by tangent of 2x plus 4. That'll get it out of the denominator and make life a little bit easier to work with. So I'll have tangent of 2x plus 4. All of that times 1, that's nice and easy, equals 3. Then I need to subtract 4 from both sides to get tangent of 2x equals -1. And now, drum roll please, it's time to go to the unit circle. Where does tangent equal -1? So I know where tangent equals +1. It's going to be at pi over 4. Now there's a few other places on the unit circle that look like pi over 4. We have pi minus pi over 4, which equals 3 pi over 4. That's over here. We have pi plus pi over 4. That's 5 pi over 4 over here. And we have 2 pi minus pi over 4, which is 7 pi over 4 over here. In which of those places do I have a negative tangent? Well, there's a few different ways you can think about that. One is using this acronym All Students Take Calculus, which tells me that tangent is going to be positive in quadrants 1 and 3, which means that it'll be negative in quadrants 2 and 4. So it might be tempting to say that x equals 3 pi over 4 and x equals 7 pi over 4, but it's not quite like that. Once again, we're going to have to branch this off into two different equations. We'll have that one of my equations says that 2x equals 3 pi over 4, and I'm going to come back to that. And the other says that 2x equals 7 pi over 4. Now, technically, I did something a little extra here, which you can get away with, and I'll make a comment on that later. So I have this, but for both of those, I could go around the unit circle more times. So to represent that, I need to add a plus 2 pi k. And now that I have this, I need to finish solving for x. X is being multiplied by 2. To cancel that out, I'm going to multiply both sides by 1/2. This is a little nicer than dividing by 2 because it makes it easier to work with all the fractions that are going on. So over here, I'll get x equals 3 pi over 8 plus 2 pi k times 1/2. That's just going to be pi k. And over here, I'll do the same thing, multiply both sides by 1/2. I'll just do that. We'll get x equals 7 pi over 8 plus pi k. Now, there's another option you have here. With tangent and tangent only, well, also cotangent if you want to get specific about it, you don't actually need to find two different solutions. You actually only need to find one solution. And then you find one solution and you're going to use pi k instead of 2 pi k. What do I mean by that? So instead of breaking this up into 2x equals 3 pi over 4 plus 2 pi k, and 2x equals 7 pi over 4 plus 2 pi k, since this is tangent, I'm allowed to just write that 2x equals 3 pi over 4 plus pi k. Why does this work? Well, if k equals 1, that's going to get me over to 7 pi over 4. So this accounts for both of these sets of solutions. And then we go ahead and multiply by 1/2 like we did before. And you could also write this answer as x equals 3 pi over 8 plus pi k over 2. So that would be another way that you could write this. Okay, that's enough math for this video. We're going to continue with some more solves in the next video and maybe move on to some other types of questions.